In this video, I want to just remind you of a few limit definition things, and I also want to do just a couple of using L'Hopital's rule and the definition of derivative. But let's start with this. I want to know if what k would need to be so that this function's continuous. Now, to be continuous, remember there are four things. The limit from the left side, the limit from the right side must be the same. The limit must exist, and the limit must be the same as what the function's value is at the point. Well, all of that is really, overboard for what this problem is, because to make something continuous, if I plug in 2 to here, I get 4k. If I plug 2 in to here, I get 4 plus 2k. And to be continuous, those two things must be equal. So I set 4k equal to 4 plus 2k. Subtract 2k from both sides, I get 2k equals 4. So k is 2. Next, let's look at this. This is an old free multiple choice question from an AP exam. It says the function, it gives a piecewise function, is not continuous at x equals 2 because g of 2 is not defined. Well, g of 2 is defined. They tell me that g of 2 is negative 5. So that's out. Next, it says the limit does not exist. Well, let's see. If we plug in 2, I'm just going to make a note. 2 minus 5 is negative 3. I'm just going to make a note there on the side, okay? Then let me plug it in to the bottom. Okay? 5 multiplied by 2 minus 13 is negative 3. Now, the fact that it's approaching negative 3 from both sides, but it doesn't happen to be defined there, it's defined as negative 5, just means it's doing something like this. Right? Where it's approaching a y value of negative 3 from both sides, but then defined as negative 5. But the limit exists. The limit's negative 3. So the limit does exist there. The next choice says because the limit doesn't equal the function's value. That is the reason it's not continuous. The limit is negative 3. That's what it's approaching. But the function's value is negative 5. So this is what makes it not continuous. Okay. Finally, looking over here at these two limit problems, pretty easy limit problems, I hope. If I plug in 0, and remember that's how we always want to start, on the top, 0 minus 8 is negative 8. 0 minus 4 is negative 4. So the limit is just 2. Okay. Of course, it's very common for people to look at that and just right away in their minds say, well, geez, they're obviously going to ask me to plug in 2 because it's going to make it 0 over 0. But they're not. Okay, don't read the statements very carefully. All right, now let's plug in 1/3. 1/3 squared is 1/9, so 9 times 1/9 is 1. Minus 1 is 0. 3 multiplied by 1/3 is 1, minus 1 is 0. Now we invoke L'Hopital. Right. So we're still going to do the limit as x approaches 1/3. We're going to take the derivative of the top, which is 18x, and the derivative of the bottom, which is 3. And we're going to plug in 1/3 again. Well, 18 multiplied by 1/3 is 6. 6 divided by 3 is 2. Up here you see the definition of derivative. F of x, the limit as h approaches 0 of f of x plus h minus f of x all over h. We do a lot of limits, and there are a lot of limits in the AP exam that look like that. And a lot of times people think, oh, it's a really hard limit. But in fact, if you know that this is the definition of derivative, you can actually do the problem very quickly. For instance, this very first one, 2 multiplied by x plus h squared minus 2x squared all over h. Well, first of all, if you plugged in h, you'd get 2x squared minus 2x squared, which is 0, all over 0. You could use L'Hopital's rule here. Okay? What you need to remember is that L'Hopital's rule, in this case, the variable is h, so you'd need to kind of work around that. But all this is really saying is what is the derivative? What is dy dx of 2x squared? Okay. Take the y out. It's just what's the derivative of 2x squared? Well, it's just 4x, and that's it. So we don't need to actually do the limit. We don't need to expand it and then factor out the h. We just need to recognize the definition and say this is obviously the definition of derivative, f of x plus h minus f of x all over h. Now this one looks a little different because it's not x. Well, what this is saying is what's the derivative of sine at pi over 2. That's it. So you just kind of say, well, let's pretend these are x values. Okay, what's the derivative? Well, the derivative of sine is cosine. The cosine of pi over 2 is 0. That's it. Okay. And finally, this last question, of course, is saying, well, what's the derivative of e at 3? Okay, what's the derivative of e to the x at x equals 3? Well, of course, derivative of e to the x is e to the x. So it's just e cubed. Now, you could also do that with L'Hopital's rule. Every single one of these problems, if you forgot the rule. And let me just take you through how you would do that. Going back here, so you plug in 0 for h, you get 0 over 0. So you take the derivative. Remember, h is your variable. Derivative of sine of pi over 2 plus h is cosine of pi over 2 plus h, multiplied by the derivative of the inside, but that's just 1, because h is the variable, so the derivative of h is 1. Minus, well, since h was the variable, this is a constant. The derivative of a constant is 0, and the derivative of h is 1. Now you evaluate the limit again. Well, you plug in 0 for h. Cosine of pi over 2 plus 0 is cosine of pi over 2. Minus 0 over 1, well, there's the cosine of pi over 2. So you're going to get the same thing using L'Hopital's rule. You can certainly use it. Of course, up here you could do that. You could say, well, the derivative of this first thing is 4 times x plus h to the first minus 0 over 1. And again, you plug in 0 for h, you get 4x. So you can use L'Hopital's rule to do this. It might be easier not to. Okay, you just need to remember that h is the variable and x is just a number.